Hi guys, so today we'll talk about fine tuning with Unsloth. So this is text generation with tiny llama using Hugging Face transformers. So our objective is to generate human-like text completions based on a given prompt using a compact and efficient language model. So for that we will import libraries, will define model name, and um, we'll load the tokenizer and model for casual language modeling, and then we'll set the evaluation mode, and after that we'll move model to GPU if available, and then this is our example input. The food was great and service was fast. This is the review, and based on this we'll generate text, then we'll decode and print the output. So generated output. The input was the food was great and service was fast. Sentiment, the staff were friendly and helpful. Rating is 5 out of 5. So this was fine tuning. And second one is continued pre-training on sloth. So we are training on sloth. For that we first install transformers dataset, then extended retraining on specialized domain corpus. Will import required libraries, will load the pre-trained model, and we'll load the dataset here. We'll tokenize the dataset for language modeling. For that, we'll convert to Hugging Face dataset and tokenize the function. And then we'll define training configuration and hyperparameters. Then we will train the model. So this is how we'll do this collab. Then in the third part, we'll do chat templates, use cases overview. So in this collab, we will implement 4 distinct use cases to explore different capabilities of language model: classification, conversational chat, extend context size, multi-data set, single fine-tuning. For that, first we will install dependencies, then multitask fine-tuning with chat templates, and we'll import all the required libraries. We'll load the base model. Then use case 1 intent classification dataset, use case 2 conversational dataset, use case 3 extended context simulation dataset, and use case 4 combine all datasets into a unified training set. Then we'll set up training arguments. We'll train model on multiple chat template tasks. So this was third part. Now in the fourth part, we will do preference optimization techniques, DPO, ORPO, which is direct preference optimization, and open-ended response preference optimization. This is first we'll start with DPO, simulated direct preference optimization. For that, we'll install transformers, required libraries, then we will import required libraries, we'll load the retrain model as usual, we'll load the preference dataset, we'll combine the prompt and choosing completion as positive example, then we'll combine prompt and rejected conclusion as negative examples, and then combine positive negative examples into one dataset. So basically we'll merge that, and then we'll tokenize the combined dataset. After that we'll set up the trainer for fine tuning, and then we will train the model with simulated DPO. Then we will test the model output after training. As you can see, user said, how do I reset my password? And I said, yeah, I'm not sure. And then we'll move on to simulated RPO, which is open-ended response preference optimization. For that, we'll first install required libraries, then import required libraries. Uh, we'll load the pre-trained model for RPO, load the dataset, combine prompt, tokenize it, define training arguments, initialize trainer, train the model on good completions, test the model output after RPO training. And as you can see, user said, how do I boil an egg? And session I boil an egg. Then after that, we'll move on to continue fine tuning custom checkpoint. So what does continue fine tuning from checkpoint mean? So instead of beginning fine tuning from a base model that is this GPT-2, we resume training from a partially fine-tuned checkpoint, allowing us to build our prior learning. So in this Colab, we will implement fine-tuned digital libido on a dataset, save the result model as a custom checkpoint, reload the checkpoint, and continue fine-tuning on new data. For that, we will install all the required packages, then import all the required library, load the dataset, tokenize it, create initial dataset for first round of fine-tuning, train the initial model, and save checkpoint. We'll reload from custom checkpoint and continue fine-tuning again. Then inference will test the model after continued fine-tuning. So as you can see, we just said what is the currency of Japan. The currency of Japan is yen, and model works fine, right? The currency of Japan is yen, and the currency of Japan is the yen. So now we'll go to mental health chatbot fine-tuning. First, as usual, we'll install required dependencies and import all the libraries. We load the model, load the dataset, wrap the raw data into Hugging Face dataset, tokenize the dataset, training arguments, and we'll do fine tuning of the model, inference chat with the bot. So, as you just said, I'm feeling very, very stressed at work. Susan said, you're a bit like a person. It's like I'm feeling really stressed at work and all that stuff. So, at last, we will move on to inference via Olama. So Olama are run locally with CLI chat interface. For that, we will install libraries, import it, load the dataset, yeah, grab the raw data into plugin page, tokenize it, set up training argument, model fine tuning, then inference chat with the bot, and export fine-tune model for you to use with Olama. Then we will load the model and tokenize it. Then at last we'll save the final fine-tune model and tokenize it. And we will download the zip file of the fine-tuned model. So this was uh, training using of LLM using Unsloth. So thank you for watching.